Welcome to this explainer. Okay, so today we're taking something you do literally every single day, completely on autopilot, and we're going to pop the hood. We're tracing the exact millisecond by millisecond journey of your data.
Think about it. You type in an address, hit enter, and bam, a page appears. But what actually happens in those crucial, invisible milliseconds between your keystroke and your screen lighting up? To figure this out, we'll trace a single click across 5 key milestones. We've got getting online via the ISP, finding destinations with IPs and URLs, the Internet Phone Book known as DNS, browsers and search engines, and finally, web servers versus application servers.
All right, let's kick things off with milestone number 1, getting online, and the role of the ISP.
So our data's journey begins at what is basically the ultimate internet toll road, the Internet Service Provider, or ISP. You know the big names, right? Organizations like Verizon, AT&T, or Google Fiber. Well, they do a whole lot more than just lay fiber optic cables. They actually allocate your IP address, they act as your frontline spam filter, and they manage the physical gateway between your local device and the entire global web. And we actually interact with this gateway constantly without even realizing we're doing network management. I mean, think about it. Checking your data usage caps, running those quick speed tests, or just configuring a home Wi-Fi password. These are all direct interfaces with your ISP's infrastructure. They really are our constant everyday gateway to the online world.
Moving right along to section 2, finding destinations using IPs and URLs. Okay, so once we're past the gateway, your data absolutely needs a destination. Every single device on a network requires an IP address, which is basically the exact digital GPS coordinates of the network. Identifying a specific device and locating it so communication can actually happen, that is the entire core of the system. And within that, the subnet mask acts as the strict dividing line. It tells the router exactly which block of numbers belongs to the broader network and which part pinpoints the specific host device.
But let's be real, us humans absolutely hate memorizing long strings of numbers. So we use URLs instead, which stands for Uniform Resource Locators. It's actually an incredibly dense set of instructions packed into just one line of text. It commands the protocol, targets the specific domain name, hits a network port, traces the exact file path, and can even pass along query parameters. It is literally the ultimate set of turn-by-turn directions for your browser. Which brings us to section 3, the Internet Phone Book, or DNS. Now, because networks only read those IP addresses we just talked about, the Domain Name System, or DNS, has to translate our text-based URLs. It navigates this very strict hierarchy, moving from the root level all the way down to generic domains like .com and country-specific domains like .au. And here's a fun fact for you. DNS caching is so aggressive and efficient on a global scale that this massive tree traversal usually resolves in under 50 milliseconds. It makes the whole translation process completely invisible to you. Let's dive into section 4, browsers and search engines. So with our destination translated, we need a vehicle to actually get us there. The race to organize the Wild West of the web was incredibly brief, but man, was it explosive. We literally went from Archie simply matching basic file names back in 1990 to web crawler introducing keyword search just 3 years later. Yahoo built the ultimate web directory, but then, by 1998, Google's algorithm showed up and completely shifted the paradigm of how we discover information. Here is a crazy thing to think about. When you actually hit enter, you aren't searching the live web at all. Nope. Your parsed query is instantly matched against massive index files. These are pre-populated by absolute fleets of web crawlers that are out there scraping the internet 24/7. The search engine just ranks those indexed results and fires them back to your browser almost instantaneously. It's like a magic trick. Finally, we reach section 5, web servers versus application servers. People so often use the word server interchangeably, but the architectural difference is absolutely vital here. A web server provides the run environment for basic web applications. They're highly efficient, consuming far fewer resources because they primarily deliver static content, things like fixed text and standard images. An application server, on the other hand, provides a run environment for heavy enterprise-level applications. They utilize intensive resources for dynamic content, processing complex logic, managing user data, and computing in real time. Actually, a good way to think about it is this. Web servers are kind of like the static storefront handing you a standard printed menu. While application servers, they're the loud, busy kitchen in the back, cooking up your custom, dynamic orders. When you look at it architecturally, the divide is really sharp. Web servers like Nginx handle lightweight HTML and HTTP tasks with relatively low fault tolerance. But application servers like Glassfish, those are heavy-duty. They support multi-threading, they run web and EJB containers, and they utilize much heavier protocols like RPC and RMI. They're designed with massive fault tolerance for a reason, because they're executing mission-critical enterprise transactions that absolutely, unequivocally cannot fail.
So the next time a web page loads in the blink of an eye, just remember the unbelievable, invisible journey that just happened. Your simple request routed through an ISP, queried a global DNS hierarchy, parsed a massive crawler index, and triggered enterprise application servers across the globe. Ask yourself, in those few milliseconds, did your data just travel farther than you will all year? Thanks for joining me on this explainer. Keep wondering, keep learning, and I'll catch you on the next deep dive.